Hi, welcome to Electrical Motor Control DEO 2053 course. Let's start with three-phase squirrel cage induction motor, one of the most commonly used types of electric motors due to its simplicity, durability, low cost, and high reliability. It is widely utilized in industrial applications such as driving pumps, conveyors, compressors, fans, and various types of machinery, making it a vital component in the field of industrial automation and electric drives. The motor operates on three-phase AC power, making it highly efficient and capable of delivering significant torque at low speeds. To provide a more detailed overview, let's explore the motor's design, operating principles, advantages, and applications in depth. The basic design of a three-phase squirrel cage induction motor consists of two main parts, the stator and the rotor. The stator is the stationary part of the motor and consists of core, made of thin, laminated silicon steel sheets to reduce eddy current losses. The stator core is essential for supporting the magnetic field generation. Windings. The stator contains three sets of windings spaced 120 degrees apart from each other. These windings are made of copper wire and are placed in the stator slots. When a three-phase power supply is applied, the windings create a rotating magnetic field. The rotor, located inside the stator, is the rotating part of the motor. The most common type of rotor used in three-phase induction motors is the squirrel cage rotor, which gives the motor its name. It consists of core. Similar to the stator core, the rotor core is made from laminated steel sheets to minimize eddy current losses. Bars. The rotor contains parallel conductive bars, usually made of copper or aluminum, which are placed in slots around the rotor's circumference. End rings. These conductive bars are short-circuited at both ends by two end rings, forming a closed loop that resembles a cage structure, hence the name squirrel cage.
Hi, I'm Hanafi Isa, and today we'll talk about modern motor control, focusing on how electronic motor controllers help industries control motors more efficiently and save energy. In industrial settings, motors are used everywhere, from pumps to conveyor belts. Traditionally, motors ran at full speed even when it wasn't needed. But with modern motor controllers, we can now manage motor speed more precisely. One key tool is the variable frequency drive, or VFD. A VFD adjusts motor speed by changing the frequency of the electricity supplied. This allows the motor to run only as fast as needed, reducing energy consumption and costs. For example, a pump can run slower when demand is low, using less power. Another useful device is the soft starter, which helps motors start smoothly. Instead of jumping to full speed, the motor ramps up gradually, saving energy and reducing wear on the equipment. This is especially helpful in industries where motors frequently stop and start. Why does this matter? Industrial motors use a lot of electricity, and with tools like VFDs and soft starters, industries can save up to 30–40% in energy costs. These savings not only lower operational expenses, but also reduce the environmental impact. In short, modern motor controllers, like variable frequency drives and soft starters, make motors run more efficiently, saving energy and money. They are essential in making industries more sustainable. Thanks for watching, and I hope this gives you a clear understanding of how motor control technology is improving the way we use electricity in industries.
Hi, I'm engineer Mohammad Hairul Nizam bin Mid Asa will explain about slip ring motor. A slip ring motor, also known as a wound rotor motor, is a type of induction motor that offers high starting torque and speed control, making it ideal for heavy-duty applications. Unlike the more common squirrel cage motor, slip ring motors have rotor windings connected to external resistances via slip rings and brushes. This allows for easier control over the motor's performance, especially during startup, by adjusting the rotor current. Slip ring motors are commonly used in cranes, conveyors, and pumps where smooth acceleration and speed control are critical. However, they require more maintenance due to the slip rings and brushes, making them more complex than standard motors. In summary, slip ring motors are valuable for tasks requiring strong starting power and flexible speed control, but they come with added maintenance needs.
Welcome to today's lesson on motor starter wiring. Electrical motors need a lot of current to start, especially when they're powering heavy machinery. That's where motor starters come in. Today, we'll cover 3 common types: the direct online starter, the star-delta starter, and the auto transformer starter. First up, the direct online starter, or DOL starter. This is the simplest type of starter. It connects the motor directly to the power supply, providing full voltage from the start. It's straightforward, but because it gives the motor full power immediately, it draws a high starting current, up to 6 to 8 times the motor's normal running current. That's why DOL starters are used mainly for small motors, where high starting current won't damage the system or overload the supply. Next is the star-delta starter, used for larger motors. It reduces the starting current by about 30%. How? The motor is first connected in a star configuration, which gives it only a portion of the full voltage. After the motor speeds up, it switches to the delta configuration, allowing full voltage for normal operation. This method is effective for reducing the stress on the motor and electrical system during startup. It's commonly used in industrial applications where motors need to start smoothly. Lastly, we have the auto transformer starter. This uses a transformer to step down the voltage applied to the motor during startup, reducing the current. Once the motor reaches a certain speed, it switches back to full voltage. The auto transformer starter is particularly useful for very large motors that need a gentle start but high power during operation. It provides more control than a star-delta starter and is often used in heavy industries.